In the same area, you will find a worksheet called 8.2, Balance Equating Using Symbols or something similar. So, magnesium plus bromine forming magnesium bromide. For bromine, you can see it's Br2, so really we need to have 2 bromines there. Magnesium bromide, 1 magnesium and 2 bromines. So to balance this equation, we don't need to do anything, because there is 1 magnesium on each side and 2 bromines on each side. Hydrogen plus fluorine going to hydrogen fluoride. H2 plus F2 goes to HF. We can see on the left there are 2 hydrogens and only 1 hydrogen on the right. On the left there are 2 fluorines but only 1 fluorine on the right. So we'll need to increase the amount of hydrogen and fluorine on the right. So we put an extra hydrogen fluoride molecule in. We will now have a balanced equation. Hydrogen plus oxygen going to water. If we look at this, we currently have 2 hydrogens on the left, 2 on the right. On the left we have 2 oxygens and on the right 1 oxygen. So what do we need to do? We need to increase the amount of water. So if we increase the amount of water by putting a 2 in front of H2O, that means we'll have doubled the amount of hydrogen. So we have 4 hydrogens, double the amount of oxygen present in H2O, we have 2 oxygens. So the oxygen is now balanced, but the hydrogen isn't. So if we increase the amount of hydrogen molecules by 1 by putting a 2 in front, this means we will now have 2 lots of H2, so 4 hydrogens on this side and 4 hydrogens on that side. Don't forget to pause the video and keep on going back to your worksheet and giving it a go. So potassium plus chlorine. Chlorine we can see is not balanced. 2 chlorines on the left but only 1 on the right, so we need to increase the amount of potassium chloride. So we'd put 2 in front of potassium chloride to work towards balancing it, like so. And we can see we have doubled the amount of chlorine on the right, so the chlorine is now balanced, but the potassium isn't. So we now need to put a 2 in front of the potassium, like so, and we now have a balanced equation. Don't forget to pause the video before doing the next one and giving it a go yourself. Magnesium plus oxygen going to magnesium oxide. We've got 2 oxygens on the left. We've only got 1 on the right, so we'll need to increase the amount of magnesium oxide by 1. And on the left we've got the oxygen balance, but the magnesium isn't yet, so we'll need to double the amount of magnesium to make it like so. Potassium plus oxygen goes to potassium oxide. If we look first, the oxygen is not balanced. There's 2 on the left and 1 on the right, so we can increase the amount of potassium oxide. I'm going to have to just do it a little bit strangely, because obviously I haven't given myself enough space on this to do it properly. But if we double the amount of potassium oxide, we've now got 4 potassiums here and 2 oxygens. The oxygen's balanced, but potassium still needs to be balanced, so we will need to put a 4 in front of potassium, like so, to make sure we've got the same amount of stuff. Potassium present, so we'll have 4 potassiums plus O2, 1 O2 forms 2 K2O. The extension question is the aluminium plus the oxygen. So let's start with the aluminium first. There are 2 on the right, 1 on the left, so let's double the amount of aluminium on the left. So that gives us a 2, so the aluminium is balanced. The oxygen is 2 on that side, 3 on that side, so let's increase the amount of oxygen on the left. So let's try doubling it. We can see this still hasn't quite worked because we've got 4 on the left and 3 on the right, so we double the amount of aluminium oxide. So we now need to add some more oxygen still to balance the oxygen out between the left and right hand side, putting a 3 there. We've got 4 aluminiums on the right, so we need 4 aluminiums on the left, so we put a 4 there. The next one, calcium plus cold water. hydrogen is the first thing which strikes me as not balanced, just looking at the coloured circles. So that means we'll need, and also the oxygen as well, so that means we'll need some more water on the left. Put a 2 there. Now that's balanced. Let's just move that slightly out of the way for ease of the next question. Nitrogen plus hydrogen goes to something called ammonia, which has the formula NH3. First thing which looks not balanced to me is for nitrogen, so yellow dots. So let's put some more NH3 there. Next thing which is not balanced is for hydrogen. We've got 6 on the right, 2 on the left, so let's put some more hydrogen there. That's now balanced. Sodium and water. Always think about maybe making something even. There's 2 hydrogens on the left, 3 on the right. So to make it even, the easiest thing to do would be putting some more sodium hydroxide present. We've got 4 hydrogens on the right, so we need 4 hydrogens on the left. The oxygen is now balanced, as is the hydrogen, and the only thing left to balance is the sodium, so we need to put 2 in front of the sodium. Iron plus chlorine going to iron 3 chloride. Iron is currently balanced, chlorine isn't, so we could add some more chlorine first to the left. That's still not balanced, so we could add some more iron chloride to the right. So we've now got 2 of those. We still haven't got enough chlorine on the left, so we need to add some more chlorine here, like so. And ions, we'll need to have 2 there to balance it. 2 final questions. Hydrogen isn't currently balanced, so we'll need to add some more hydrogen to the left. And that is now balanced. 1 magnesium on each side, 4 hydrogens on each side, 2 oxygens on each side. So the last question, which we need to obviously balance, is this one. 1 magnesium on the left, 1 magnesium on the right. 2 hydrogens on the left, 2 hydrogens on the right. 1 oxygen on the left, 1 oxygen on the right, so it's already balanced, so we don't need to do anything. Excellent.